All right, so our next question is a question about encryption, question 3. So there's a student from Arizona called Brian, and he's sent us a secret message encoded as a bunch of like ASCII characters, but it's a secret message. It's been encrypted, and the way we want to decrypt the message is we've got a secret key, OX55, and we have to XOR that key with each byte of the message. Okay? So essentially what we're going to have to do is we're going to have to do the load, twiddle, store pattern that we learned about in labs. We're going to load a byte from the secret message, we're going to twiddle it, we're going to XOR it with the key, and then we're going to store it back. But we're not going to store it in the same location, we're going to store it in this different location decoded. And the reason why we do that is so we can see the original bytes compared to the new bytes in the memory viewer. So let's do that. So how are we going to do this? So the first thing is we're going to set up our registers for where we're loading from and where we're loading to. So I'm going to let the R0 register to denote where the message is. So this is the ciphertext. R1 will point to where we're going to store the decoded message, which I call the plain text. And then R2 will contain the secret key. So to obtain the secret key, what we can do is we can just load directly into R2 where key points. So don't get mixed up between these two things. What this command here is doing, it's loading the memory address that decoded represents into R1, whereas this one here is loading the key directly. So it's going to this memory address and it's fetching this byte and it's storing the result directly into R2. All right. So we've got our memory addresses set up, so let's get to work. And again, the last byte, this is a null terminated string. So when we read a 0 from memory, we know the message is over. So I'm going to load from where R0 points, and I'll store it into, say, maybe R5. So R5 will contain this byte of the ciphertext. And because these are all bytes, each byte takes up 8 bits. I want to use an LDRB to load a single byte. And after each load, I want to increase the value in R0 by 1. So this is load with a post offset by 1. So the intended effect, it's basically doing 2 instructions, one after the other. R5 is going to equal the thing that was in R0. And then afterwards, R0 is made 1 bigger. So it's basically do a load and then do an offset afterwards. Okay, so R5 contains the first byte of the secret message. We're going to XOR R5 with the key. So now in R5 it contains the decoded byte. And then we're going to store strb, store a byte. We're going to store R5 into where R1 points and then increase R1 by 1 afterwards. So this command here is essentially saying whatever R1 points to, copy the value from R5 into it, and then increase R1 by 1. Plus 1. Okay? I suppose nowhere here did I check if the byte was 0, so I'd better do that too. So before we do the XOR, I will check. I will compare R5 with 0, and if I load it as 0, I will branch to end. And otherwise, I'll do the XOR, store the byte back, and then I'll branch back to decrypt and do the whole thing over again in a loop. Alright, so let's see if it works. So we'll build it. And this time, whoops, made a mistake. Alright, it doesn't like, okay, so first off, XOR is EOR, not XOR as you would hope it to be. And secondly, it doesn't look like I can actually load from a label directly. So what I will do instead is I will... Oh, you write it like that, my mistake. Yeah. When you're loading from a label, you just write the register you want to load into and the name of the label. So when I put an equal sign here, it's loading the memory address the label represents. Here, it's loading from that memory address. So don't get the two things confused. All right, let's try that again. Still unhappy? All right, looks like I have to do this in 2 stages. So I'll load key into R2 and then LDR from where R2 points into R2. All right, so this is fetching the memory address, and this is fetching what the memory address points at. There we go. That should make things work. And there we go. It's happy. Let's turn on the debugger, and then we'll also turn on the memory viewer so we can see the message be decoded in front of our eyes. All right. So set a breakpoint at main. Fly through the code. Okay, here we are already at main. We got our Cortex register, we got our registers, we can see. I'm also going to open the memory viewer. So view memory. Where do I want to view? I want to view at the start of data. So that's going to be OX2 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. And I'll load, I don't know, lots of bytes. 200 bytes is a large number of bytes. So if we move this over a bit, what I'll do is actually I'll put this below. So if I click and drag this window, I can sort of put it underneath, if it'll play nice. Nope. View, appearance, where are we? Here we go. 2 rows. That looks nicer. So we can make the terminal go away. So now I've got my memory viewer down here, and I've got my code on top, so now I can see what's going on. So we can see here, the very first byte is the key, because the very first thing in data is the key. And then we have 6 is the first byte, 5 is the second byte, OX14, which in decimal is 20, is the third byte, and so on. So from here up to the 0, which is here, all this information here corresponds to the secret message before we've decrypted it. And then from this memory address onwards, we're going to store what the message looks like when it's been decoded. And then here on the right hand side, all this is doing is it's taking the bytes and attempting to decode it in ASCII. Now most of this stuff is just junk. It's non-printable characters, so we're not really seeing anything. But as we store the data back, we'll begin to see the message appear. So we load the addresses, we load decoded, we load the key. So R2 should now contain OX55, and it does not. Well, that's no good. All right, so what went wrong? So we load, aha, I didn't do an LDRB. That was the problem, because the key is only a byte large. All right, so let's try that again. So you always got to remember, whenever you do a load, are you loading a byte, a half word, or a full word? You can see I forgot myself. I forgot to load a byte, so I loaded an entire word. All right, so let's try that again. Turn on the debugger, and we'll step through the code and we'll see what happens. Alright, so skip ahead to main. Alright, so load the key, load the addresses. So here we go. R2 is now OX85, and again, this is probably better seen in hexadecimal. So R2 contains our key. And then what do? We go to the memory. Memory just pointed out by R0. We fetch a byte and we store it into R5. So hopefully R5 will contain the first byte of the secret message, which is OX06. And so it does. It contains a 6. We compare it. Was it a 0? No, it wasn't. So we don't jump to the end. Again, I'll switch this back to hexadecimal. I XOR the key stored in R2 with the byte stored in R5. And I get OX53, and I will then store that back to where R1 points. So we're going to store that here, so OX53, and you can see the first character of the secret message is an S. We branch back to decrypt, we do it again. Load the byte, compare it, is it 0? It's not, XOR it with the key, and store it to the next memory location. So we stored an OX50, which when decoded in ASCII is a P. So the secret message is S, P, and something else. So if we just put a breakpoint here at end, we can fly through the rest of the loop really fast. And here we go. So it's decrypted the rest of the message, loaded the last byte, compared it to 0, jumped to the end and got trapped in the loop. And it looks like the decoded message is 53, 50, 41, blah, 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 which when decoded in ASCII reads as space grow fast.